Alright guys, so now we are going to talk about the section 3.3, which is quadratic equation and inequalities. There is a different way to solve a quadratic equation, and the first is to factor, and then we use the zero factor property. So please try to remember the zero factor product property, which is right here, okay? If you have the product of A by B equal to 0, then that means that A equals 0 or B could be equal to 0. So when we are looking at the example number 1, we are able, and when it is easy like this one, to factor right away your expression x squared plus 5x plus 6 equals 0. We are able to factor right away. Why? Because first of all, we have a plus right here. So because you have a plus, we know that our parentheses will be made of plus, no matter what. Okay? Then, when we're having x squared with a coefficient equal to 1, we can be sure that we are going to have x right there. Now, to find the number in this, the last number inside each of these parentheses, we need to have at the end of the day that the product of these two numbers is going to be equal to 6, to the constant c of your quadratic equation. And so to make 6, when you multiply, it's going to be 2 by 3. At the end of the day, we end up to have x plus 2 times x plus 3 equals 0. Using the zero factor property, we are able to say that x plus 2 equals 0 or x plus 3 equals 0. We end up to have two solutions for x equal negative 2 or x equal negative 3. We're having exactly the same thing on the example number 2. And on the example number 2, it is very easy to understand that if you have x squared equals 4, well, you are using now the second way to solve a quadratic equation, which is to use the square root property. And when you are using the square root property, you are supposed to have that the x is going to be equal to plus or minus k. So in this case, you're going to have x equal plus or minus the square root of 4. If x is going to be equal to the square root of 4, we end up to have plus or minus 2. So you will notice that there is a tiny mistake, and right there you are supposed to have plus or minus 2 as a solution. The last one is sometimes we can't factor a quadratic equation. So for that, you are going to have to use the quadratic formula. And so you need to remember this quadratic formula. Okay, perfectly well. That is very important for you to do so. The only point is, every time you are using this formula, you need to understand that this formula has been done through this general form of a quadratic equation, and so you must pay attention to the value of A, to the value of B, and to the value of C. For that, if you look at the general expression, you have a plus written in general form. So when you don't have a plus, what I would suggest is you can do from there to there by having the 7 going to the other side and having equal to 0, and then just put a plus right here. Okay? By putting a plus, you don't change your equation, because plus by minus will still be minus, but this time you will be able to define properly that A equal 2, that B equal negative 15, and that C equal negative 7. Most of the time, I see students making a mistake because by not putting the plus, okay, by not putting plus right here, I have students telling me that A equal 2, okay, that's pretty easy, but B equal 15 and C equals 7, which is not the case, okay, which is not the case. So adding the plus help you to definitely see that A equal minus negative 15 and B equal negative 15, I'm sorry for that, and C equal negative 7. So you just substitute this value of A, B, and C inside your formula, and you will have the value of x. And in this case, you will have two values of x. The first value of x is going to be 15 plus the square root of 281 divided by 4. And the other one, x, is going to be equal to 15 minus square root of 281 divided by 4. So if I want to solve this quadratic inequality, the first thing I want to do is to say that the zero factor property is going to give me x minus 4 equals 0, x equals 4, and x plus 3 equals 0, so x equals negative 3. So this results in negative 3 and 4 as a 0, and to determine which interval we need, we have to make a number line. So I'm going to make a number line. Plot my 0, and of course my 4 is going to be right here, and my negative 3 is going to be on the left side of my 0. Then to check the interval of number less than negative 3, what I see is I have one interval, a second interval, and a third interval. Okay, so I want to do is pick a number which is going to be in the interval number 1. Why not picking the number negative 4? Then pick a number in my interval number 2. Well, why not picking the number 0? And then pick a number in my interval number 3. Why not picking 5? Okay? Once I'm done doing this, I am going to take this value and substitute this value inside my inequality right here. Okay? So let's do the number for negative 4. So let's take a look for x equal negative 4. Well, I'm going to have negative 4 minus 4 times negative 4 plus 3. That gives me a negative 8 times negative 1. And negative 8 times negative 1, it's equal to plus 8. And it is greater than 0. Now, if I look at the other one, I'm going to take 0. So I'm going to have, it's a 0 for the 0. Okay? I'm going to have 0 minus 4 times 0 plus 3, which is going to be equal to negative 12. And that is not greater than 0. I would like to remind you that I'm looking for if it is greater than 0 or not. The last part is going to be when x equals 5. And if I'm looking x equals 5, I have to deal with 5 minus 4 times 5 plus 3. That gives me a 1 times 8. And that is greater than 0. Alright? So I can clearly see that there is two intervals where the value of x will be checking this inequality. It is the interval number 1 and the interval number 3. So the interval notation is going to be negative infinity, negative 3, union 4, union 4, plus infinity. Let me erase that. Union 4 plus infinity. Now guys, I'll let you read the example number 5 on your own, and you will be able to understand that the main idea is to try to define what is the variable I'm looking for, and now you know what is the variable, try to isolate this variable following the rules that you have learned in the previous sections. So, in this page number 2, zero factor theorem, example 1, 2, 3, 4, and 5, as well as 6, 7, 8, 9, and 10. Actually, I'm going to do the number 10. with you. Please do all the example until the example number 9, and let me do the problem number 10 with you. So if I want to solve this inequality, the first thing I want to do is try to solve x squared negative x minus 12 equals 0. If I want to do that, first of all, I'm going to put a plus right here. Now I'm able to say that a equal 1, b equal negative 1, and c equal negative 12. If I want to solve using my formula negative b, so negative 1, I'm going to use a parenthesis every time I'm using a negative number, divided by 2a, so divided by 2 by 1, minus, plus or minus, square root of b squared, so negative 1 square, minus 4 times a times c, which is minus 12. Minus 12. Divided by 2a, divided 2 by 1. So we're having x equal 1 over 2 plus or minus square root of 49 divided by 2, which is x equal 1 over 2 plus or minus 7 divided by 2. That gives me two values of x. The first one is going to be a divided by 2, which is 4, when the second one is going to be 1 minus 7, negative 6, divided by 2, negative 3. Once I find the two values of x, are supposed to be the zeros, I'm drawing my interval, I'm plotting my zeros, so now I know that 4 is going to be right here, and negative 3 is going to be right there. That defines three intervals, interval number 1, interval number 2, and interval number 3. I'm going to take 0 in this interval number 2, I'm going to take negative 4, and I'm going to take 5 in the example, respectively, in the example 1, in the interval 1 and interval number 3. Once that is done, I'm testing the x equal negative 4. So if I'm looking right here, so I'm going to do is I'm going to use the black one, and I'm going to separate my interval, and I'm going to have is negative 4 square, minus negative 4 minus 12. Negative 4 square, it is a 16. Minus negative 4, it's a plus 4. Minus 12. And that is a 24 minus 12, which is 12. This is positive. So this interval, I don't have any solution. Now if I take x equals 0, I'm getting a 0 minus 12. This is less than 0. This is okay. This is okay when this one is not okay. No, not okay. Alright, then I take x equals 5, I got 5 squared minus 5 minus 12, 25 minus 17. This is going to be positive, and I'm supposed to have something negative, so that is a not okay. And so my interval notation is going to be negative 3, 4 in between parentheses, but because that's the only interval when I can find a solution for this inequality. Alright guys, I'll let you do the example number 11 by yourself, and I'm going to work very quickly the example number 12 for you, and you will have to do the example number 13 by yourself. The question is find D. So I have a rational equation. My LCD is equal to 4, so I'm going to multiply by 4 everywhere. Like this, my denominator 4 is going to divide out. Now I want to divide. I got 4a equal pi d squared. I'm going to divide by pi everywhere, and I end up to have a d squared equal 4a divided by pi. D is going to be equal to the square root of 4a over pi, which is going to be 2 times the square root of a divided by pi. Why I don't take plus or minus? Because usually d is supposed to be a distance, and I don't deal with, we're not dealing with negative distance. It doesn't make any sense. So at the end of the day, we're having d equal to square root of a divided by pi. Unless, on the exam, we are suggesting that you are supposed to have a negative d also, and you know that you are supposed to have plus or minus square root of, in this case, 4a divided by pi, which would be plus or minus 2 square root of 8 divided by pi. Thank you very much, and I will see you in class